This is problem number 2 on the sample test problems for test number 3. The Mitchell numbers are defined by the following recursive definition. Seeds, M1 is 1, M2 is 2. Those are the first two Mitchell numbers. And here's the recursive rule. Mn equals 3 times Mn minus 1 minus Mn minus 2, where n is bigger than or equal to 3. So what does this really mean? Well, let's see. Mn minus 1 refers to the previous Mitchell number. And Mn minus 2 refers to the Mitchell number before that. So that means that this equation means that if you want to get a certain Mitchell number, you take 3 times the previous Mitchell number and you subtract the Mitchell number before that. And that's what that little sentence there says in the parentheses. This is a brand new definition. You're not supposed to have seen this definition before. It was actually made up for the purposes of this practice test. But let's see if we can do part A with this brand new made up list of numbers. It says list the first 10 Mitchell numbers. Okay, so M1 and M2 are easy because they're given. First one is 1, second one is 2. That's here. And then to get to M3. Okay, now we have to apply our rule. The rule says 3 times the previous Mitchell number minus the one before that. 3 times. What's the previous Mitchell number? It's this guy. 2 minus the one before that. It's this guy. 3 times 2 is 6. Minus 1 is 5. So again, it's 3 times the previous Mitchell number. It's there. Subtract the one before that. That's there. Let's go to M4. Again, it's 3 times the previous number minus the one before that. 3 times the previous minus the one before that. The previous Mitchell number is now 5. Minus the one before that, that's now 2. 3 times 5 is 15. Subtract 2, 13. 3 times the previous. Subtract the one before that. And 5. 3 times the previous number, the one we just got is 13. Subtract the one before the 13, that's 5. So that's 39 minus 5 is 34. M6, 3 times the previous, 3 times 34. Subtract the one before that. And I'll go ahead and start using the calculator as these numbers get bigger. So that one's 89. M7, 3 times the previous, 3 times 89. Subtract the one before, 34. $233. We'll write out the last few here, and then you can do the calculations. Let's see, so that's 3 times 233. Subtract the previous one, 89. You get whatever you get. And then you do M9 just the same way. And then finally M10. The answers are in the answer key at the end of this document. We'll just stop there and go to part B. It says compute the ratio of successive Mitchell numbers, M2 divided by M1. Let's start there. M2 we found was 2. M1 was 1. Divide those and you get 2. Okay, not sure where to go with that, but that one's done. Let's do M3 divided by M2. The third number in this list was 5. Divided by the second number was 2. So that's 2.5. So we're not going to go all the way through this, but let's try the next one. M4 divided by M3. The fourth number is 13. The third number is 5. 13/5 is 2.6. And let's just go ahead and jump to the last two that we have written down on this page anyway. We'll do M7 divided by M6. So 233 divided by 89. And we'll get an approximation from the calculator. And we get 2.61, just about 2.618. And so it looks like we're kind of honing in. If you did a few more numbers out here, you'd see it seems like we're honing in on something around 2.618. So that's our approximate value. And if you're really on the ball, you might recognize that that number actually is, well, it sure looks like it's around one more than the thing we called the golden ratio. Remember, we saw that in class when we filled in the big Fibonacci table. And we saw the golden ratio is around 1.618 and change, and this number goes to one more than that. Part C, explain how the Mitchell numbers are related to the Fibonacci numbers. Okay, let's just go ahead and list a few of the Fibonacci numbers, just the beginning ones. So the Fibonacci numbers start with a 1 and a 1, and then the rule is you add the previous two numbers to get the next number. So 1 and 1 is 2. Now adding the previous two numbers, the two most recent numbers you see in this list, 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8. And we just keep writing the sum of only the previous two numbers in the list. And actually, some of these numbers look quite familiar. We'll go up to the Mitchell numbers here. Let's see, we've got 1, 2, 5, 13, 34. 1, 2, 5, 13, 34. The next one up there was 89. And it sure looks like the Mitchell numbers are really every other Fibonacci number.